All right, we're going to get started with the world's shortest lecture. I want to leave plenty of time because we are going to be playing a game momentarily. Assignment due Sunday. I still need to get something up for that. I realize that every single day, right at this time. It's becoming a daily occurrence. All right, to get to the game, we just have to get through a couple things. First is when to use cards or card-based ideas in game mechanics. So probabilities for different concepts out of cards. Particular card about 2%, specific suit 1 in 4, color 1 in 2, face card about 23%. And if you want to use cards as the baseline of a probabilistic event, you can do things in pairs or triples. Say if you draw 3 cards and get at least 1 face card, then so you can customize the probability of a lot of these ideas in ways that are much more interesting than just the draw 1, what probability do you get? Of course, you can also make custom card decks. You can completely customize the number, the suits, I think Balatro did a really good job of customizing, taking a basic deck and allowing you to customize the heck out of it in ways that worked well for its mechanics. So there's nothing to say that cards can't do. There's not really a limit to what they can do. It's just the limits of your creativity with using them as game objects. The important concept for cards is when should you shuffle a deck? And this just creates the with replacement or without replacement effect. So if you shuffle when the deck is exhausted, you force the theoretical probability over the large sample size or the longer term. Every 52 cards that you see, you will have seen the exact distribution that you would expect for those 52 cards. I guess casinos know this well, that if you only use a single deck, then you can card count. If you use multiple decks, it becomes a little bit harder to card count, but it's still very possible. But that could become something that is strategic in a game that you use a card-based outcome for. If you want to allow card counting, I don't think there are too many games out there that really utilize the memory of card counting as a strategy.
I only think of one game that does that.
What game is that?
It's not really much of a game, but it's like in Resident Evil 7, there's a game called 21 where it's basically blackjack, but there's only one. Every card is unique, so it's like you kind of have to card count. Like you don't know what the first card, your opponent's first card is, so you have to card count to logic out
what the possibilities are,
theoretically what their card is, and try to
you end up with conditional probability in that sense, which is good. If you know how to math conditional probability, you can come up with exact probabilities given the information that you have. If you shuffle before each draw, then it's fully independent and random, and you will only see the theoretical probability in the very long term. But that can lead to a much more interesting individual experience that you can't strategize around quite as much. And in general, if you're doing something in person, if you are doing good riffle shuffles, you can have a fully random distribution of your deck of cards after about 7 shuffles. All right, we've arrived at our game. We're going to get into it. The game is called Bulls and Cows. Has anyone heard of Bulls and Cows? Has anyone heard of the board game Mastermind?
Oh, yeah.
A few people have heard of Mastermind. This is the numerical version of Mastermind. So this was the theoretical basis for that board game, and it is very similar. This is played in pairs. There's a code haver or a code inventor and a code cracker. So the goal of the player is to guess the code that the other player makes. So the way we're going to play this is code is a series of 4 digits between 0 and 9. Every digit can appear in each place. We will decide before we start whether repetition is allowed or not. For each guess, the guesser will receive as feedback both bulls and cows. The bulls tell you the number of digits that were correct and also in the correct place. The cows will give you the digits that were correct but not in the right place. So Yeah, one bull for a correct digit in the correct place, one cow for a correct digit in the incomplete place. So here's an example of a game being played where the code is 9305. The first guess was 1234, and the only digit that is correct in the 1234 guess is the 3, but it's in the wrong place. So they get a cow, a single cow, as the response to their guess. They don't know it was the 3, since they aren't able to reference the secret code, but they know of those 4 digits, one of them was correct, but in the wrong place. The next thing they guess is 5678, and this gets the 5, but again, it's in the wrong place, so they get 1 cow as feedback. They then guess 9087 and get 9012, and get 1 bull, 1 cow. Interesting. Turns out the 9 was correct in the right place, but there was no way for them to know that when they made that guess. And the 0 was correct, but in the wrong place. They then guess 9087 and get exactly the same result, which might hint that it's the 9 and the 0, the thing that was held in common, that were the bull and the cow. So they're going to hold the 0 in place and see if it is the 0 and get rid of the 9 completely. And that ends up being a very good guess to reveal information. The 1087 gives them a single cow. So this says that the 0 wasn't the number that was in the right place. And if it was the digit that was correct in the prior guess, then that tells you that 1, 8, and 7 for sure are not in it at all. And the 9 was the digit in the right place. So they use that information to go back to the 9, move the 0, and put a 2 and a 5 in there. And it turns out that they guessed the 5 correctly, so they get 3 bulls as they're getting closer. And then they get it correct with the 9305. Any questions on the rules of the game?
It's numerical word.
It is also numerical Wordle.
Oh yeah, I think there is a Wordle-like game that is basically just this. I forgot what it's called.
So what we are going to do is we're going to break into pairs and play it. We're going to use the base rules for the moment. And let's start by saying there is no repetition allowed in the codes. So no digit repetition is allowed. This will get you used to the strategy of guessing the numbers and utilizing that as feedback. And as you play, take some data and think about the following questions. So, what is an appropriate strategy for minimizing the number of guesses to correctly identify the number? So think about the strategy of playing the game. How can you guess the number as quickly as possible with the information? So what is the best strategy you can come up with? Yeah.
How many possible guesses until they fail?
We're actually going to come up with that. We're going to let them go on for a while, but one of the questions I'm about to reveal is if you're designing the game for sale, how many guesses should the guesser be allowed before losing the game? So think about how frequently should the game be won or lost. If you're trying to find that 50th percentile, what should that be? Should they be allowed 4 guesses, 6 guesses, 12 guesses, 100 guesses? And then have reasoning for that. So also think mathematically. If you are intelligent, how much information can you gain on average from the first guess? How much information can you gain combined between the first and second guesses? Is there a way to mathematically represent this idea? And then start to think about the variables that we have in this game, like the length of the number of digits that we have available to us. So start to understand in general the mathematical shape of this game. So how do things scale with respect to length of the number of characters that we allow as digits? And then start to mess with the rules a little bit. This will be more of a Monday thing. We're going to do this over at least 2 days, possibly 3 days. But what mechanics could we add into this to make this more than a 2-player game or some kind of competitive multiplayer game? So let's start with just this on the board. And let's break up into pairs and start playing it and understanding it. I will leave this up for you to reference, but let's start with just a game or 2 of playing it to understand it.
So who's being